engineering researchers have created new high-power electronic devices that are more energy efficient than previous technologies. The devices are made possible by a unique technique for doping gallium nitride, gallium-3 nitride, in a controlled way. For example, the technology might need to convert AC to DC, or convert electricity into work, like an electric motor. And in any power conversion system, most power loss takes place at the power switch, which is an active component of the electrical circuit that makes the power conversion system. Developing more efficient power electronics like power switches reduces the amount of power lost during the conversion process, says Khachariya, who is now a researcher at Adroit Materials Inc. This is particularly important for developing technologies to support a more sustainable power. This makes it possible to incorporate these systems into technologies where they don't currently fit due to weight or size restrictions, such as in automobiles, ships, airplanes, or technologies distributed throughout a smart grid. In a paper published in 2021, the researchers outlined a technique. In other words, they engineered impurities into specific regions on GaN materials to selectively modify the electrical properties of the GaN only in those regions. In their new paper, the researchers have demonstrated how this technique can be used to create actual devices. Specifically, the researchers used selectively doped GaN materials to create junction barrier Schottky (JBS) diodes. But historically they have been made of the semiconductors silicon or silicon carbide, because the electrical properties of undoped GaN are not compatible with the architecture of JBS diodes. It just doesn't work. We've demonstrated that you can selectively dope GaN to create functional JBS diodes, and that these diodes are not only functional, but enable more power-efficient conversion than JBS diodes that use conventional semiconductors. For example, in technical terms, our GaN JBS diode, fabricated on a native GaN substrate, has record high breakdown voltage, 915 volts, and record low on resistance. We're currently working with industry partners to scale up production of selectively doped gallium-3 nitride, and are looking for additional partnerships to work on issues related to more widespread manufacturing and adoption of power devices that make use of this material, Collazo says. The paper, Vertical GaN Junction Barrier Schottky Diodes with Near-Ideal Performance Using Mg Implantation Activated by Ultra-High Pressure Annealing, is published in the journal Applied Physics Express. The paper was co-authored by Spyridon Pavlidis, an assistant professor of electrical and computer engineering at NC State, Shashwat Rathkanthiwar, a postdoctoral researcher at NC State, Shane Stein, a Ph.D. student at NC State, Hayden Breckenridge, a former Ph.D. student at NC State, Erhard Kohn. The work was supported primarily by ARPA-E as part of its PNDIODES program, under grants de Arkansas 0000873 Delaware Arkansas 000149. The work received additional support from the National Science Foundation, under grants ECCS 1916800, ECCS 1508854, ECCS 1610992, DMR 1508191 and ECCS 1653383. The Office of Naval Research Global's Naval International Cooperative Opportunities in Science and Technology Program, under Grant N6290917. Make a Difference. Sponsored Opportunity StorySource. Materials provided by North Carolina State University. Original written by Matt Shipman. Note: content may be edited for style and length. Applied Physics Express, 2022, doi 10. 35848 1880 seconds 0786, AC8F81M Hayden Breckenridge, James Tweedy, Pramod Reddy, Yan Guan, Pega Bagari, Denis Shemaisky, Seiji Mita, Kacper Sierakowski, Michal Bakowski, Ramon Collazo, Zlatko Satar. Researchers demonstrate new, more energy-efficient devices using gallium nitride. Science Daily, the 6th of September 2022. ift.tt/svnqlrg. North Carolina State University, 2022, September 6. Researchers demonstrate new, more energy-efficient devices using gallium nitride. Science Daily. Retrieved September 6, 2022 from ift.tt/svnqlrg North Carolina State University. Thanks for watching. Please subscribe my channel for more videos.